Again, welcome to Java programming. In this lecture, we are going to study about flow of control using loops. So our main objective is designing a loop, also using the while and do while loops. In Java, we have the while loop, do while loops, and also we have the for loops, and we have for each loop. In this section, we're going to study the while loop and do while loop. Again, the main reason why we normally need the loops in our program, it can be any programming language, in this case Java, is because if we want to do something over, if we want to perform a task over and over again, instead of writing the statement over and over again, we can write only one statement in a loop. Then only one statement will execute based on the loop condition. Normally, we are going to have a condition in the loop. If the condition is true, the loop will keep executing. If the condition is false, then we exit from the loop. So a very simple example, I want to find the sum of a values from 1 to 200. I don't want to write 1 plus 2 plus 3 plus 4 up to 200. That's too long. So I can use the loop, and I'll have a counter variable that I'm starting from 1 as far as we haven't reached 200. I should keep adding 1 plus 2 plus 3 till I reach 200. Then the condition becomes false. After 200, then we exit from the loop. So we will see an example. So here we say, what is a Java for loop or while loop or do while? Again, Java loops consists of 3 types. We have the for loop, while loop, do while loop. So what is a Java for loops? A Java loop statement is a portion of a program that repeats a statement. So a portion of a program that repeats a statement or a group of statements is called a loop. So that's why we said normally we need a loop. If we want to do something over and over again, we have to repeat the same task over again. So a Java loop statement is a portion of program that repeats a statement or a group of statements. And also a statement or a group of statements to be repeated is called the body of the loop. And also loop could be used to compute grade for each student in a class. In this case, let's say we have 20 students. The computation for each student, the process is the same, but they may have different scores. But since the process are the same, we can write only one process in the loop, and we can be able to calculate or execute all the 20 students, their grade. So we start with the while loop first. So what is a while statement? Here we say a while statement or while loop is a statement that repeats. So again, the key word is repeating, a loop repeats. So a while statement repeats while a constrained Boolean expression remains true. As far as the condition is true, we're going to execute. So a loop body typically contains an action that automatically causes the control Boolean expression to become false. Now, this is the problem. If the condition can never be false, we're going to have something called infinity loop, which means this loop will execute forever. It can't stop. So always we have to have a condition that at least it will reach a stage that the loop condition or the Boolean expression in the loop will be false so that the loop will stop. Unless we intentionally write it, sometimes we may intentionally write a program, let's say in a JavaScript. If I have a website or web page, I want sentences to be displayed on my screen forever. I may write infinity loop. So maybe we may have a sentences moving. Let's say Java is easy, moving throughout my web page. It doesn't stop, keep moving as far as the web page is open. So this would be an infinity loop. So let's see an example first here with the while loop, then we'll go through the syntax. So this is a program listing 4.1. We can say our main concern here is what I'm highlighting. This is our condition. If the count is less than or equal to number, then we want to print the count. Then we increment the count. Increment the count is very important because we want to reach a stage that the count will be greater than the number so that the loop will stop. So if the count cannot be increment, or if the count is decrement, then this loop will run forever because the condition here will always be true. So this program here, again, we have the scanner class. The reason why, because we want to create a scanner object. Then we ask the user to enter an input using the scanner object. Here, the scanner object name is keyboard. So we have keyboard.net next int. We are getting an integer value to the variable name number. We already declared the variable number and also the count. So we ask the user to enter the number user. Now, if user enters 0, the loop will never execute because we initialize the count to 1. So beginning, we may have count equal to 1. Is 1 less than or equal to 0? No, 1 is greater than 0. So which means we are not going to, we will not even go inside the loop at all. We just exit from the loop. Now let's say, assuming the user enter 1. So the number is 1. So we initialize the count to 1 already. It's constant 1 beginning. So is count less than or equal to number? Yes. So we're going to write execute system.out.print 1. So 1 is going to print. Then we have comma. Then we check, we increment again. Remember, count is 1. So we increment the count to 2. Is 2 less than or equal to 1? No, 2 is greater than 1. So we exit the loop. When we exit the loop, we are going to print a blank line. Then next we print buckle my shoe. So if user enter number, then only 1 will print from the loop. Then now if user enter 10, then we are going to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whatever value the user enter for number, we're going to print from 1 up to that number. So if user enter 1, we print only 1. If user enter 2, we print 2, 1 up to 2. If user enter 3, we print 1, 2, 3. Because it's 3 less than or equal to 3, yes. It's 1 less than or equal to 3, yes. It's 2 less than or equal to 3, yes. So it's going to print. So that's the syntax. We have our variable count. We initialize it to 1. Very important, we have to initialize it because we are going to use the initial value to start testing the condition. It's 1 less than or equal to the number the user enter. If it's true, we execute increment the count by 1, and we keep going. So here we are assuming we enter 2. So if we enter 2, we print 1 and 2. Then buckle my shoe. If we enter 3, we print 1, 2, 3. Then buckle my shoe. If we enter 0, the loop is nothing will happen. So it will iterate 0 times. We just exit from the loop. So this is the syntax from the program. So we initialize our count to 1. We say while 1 is less than or equal to the number. If this condition is true, we print the count value. Then we increment the count value by 1. So that's why we print 1, 2, 3. Always, every run, we are going to increment the count. And this is the flowchart, the diagram. So we start, check a condition. Is the condition true? Okay, if it's true, print the count, increment the count by 1. Come and check, is the count less than or equal to the number? If it's true, we print. And come and check again. If it's true, we print. Increment, we check again, is false, then we end the loop or exit from the loop. So the syntax for while statement is we use the keyword while, then we have our expression, then the body statement. Now, if the statement is only 1 line, we don't need the curly brace, but if we have more than 1 line, then we can use the curly brace. If we don't use the curly brace, that means the while condition will only affect the first statement. It doesn't affect the second. Same thing as we talk about the selection statement. So while the Boolean expression, the body, condition is true, we execute the body. Condition is false, we end the loop. So next is the do while loop. Now, do while loop will guarantee us that at least we are going to execute the statement once. So do while loop means do something first. So we can see the syntax here. Do execute the body statement before we check the condition. And don't forget the semicolon here, very important. You see, when we are using in the while loop, it's a condition, we don't have no semicolon. You can see here while expression, no semicolon. But with the do while, the syntax, we always end the condition with semicolon. So let's see an example, almost the same program again, but this time we are using do while. So you can see what is going on here. First, we print 1 because the count we initialize it to 1 as usual. The one we print 1, we increment the count to 2 before we check a condition. Is 2 less than or equal to the number? If it's 3, then we print 2. Is 3 less? If it's true, we print 3. Increment to 4. Is 4 less than the equal to the number? Yes, then we print. Now, if the condition is false, we exit from the loop or we end the loop. Then we print again a blank line, then buckle my shoe. So we can see the syntax here, do something at least once before you check the condition. So the syntax is do system.out.printed. So here we are printing the count, then we increment the count, then we check if the count is less than or equal to the number. As we said, if it's true, then we execute again. If it's false, we exit from the loop or we end the loop. So the syntax again, do while, we always start, do the condition, execute, then we check with the while loop. Now, it's the same as using while loop, but what will happen is that since do while, we have to execute our statement once before we check. In this case, we see we have a statement 1, execute first before we check the while, the condition, then we execute again. Then we stay, here we are, the first statement is not inside the loop, so it's out. So from here, we check the loop condition, we keep executing if it's true. If it's false, we end the loop. So this is the syntax again, do something, the body, while the condition is true, do the same thing again until the condition is false, which is the Boolean expression, then we end the loop. So here we have a programming example. This is a bug infestation. What is given to us is the volume, a roach. One roach volume is, what we mean by a volume a roach means, here we are going to write a program about bug infestation. So each roach or a bug in a room will occupy 0.002 cubic feet. So we may have a starting roach population. The rate of increase is 95% per week. We also have the volume of a house. So our goal is that we want to know how long it will take for us to occupy the whole room with roaches. Since the rate of growth is the same constant 95% per week, and also the roach volume for each is the same 0.002, we can use a loop. So we use a loop, multiply the population by 0.95, that's the growth, add it to the initial population or previous population, and we check and see if we have reached the volume of the whole house. If not, then we keep producing more, keep adding until we occupy the volume. Since we know the volume that each roach will occupy, again, we can do it. So that would be the capacity, the number of wings to exceed the capacity of the house. So this is the algorithm for roach population. First, we get the volume of the house. We get the initial number of roaches in the house. Then we compute the number of weeks until the roach house is full of roaches. So then we display the result. Compute the number of weeks until the house is full of roaches. This is where we are going to write our loop. So we have to keep computing every week until the house is full of roaches, or the roaches again, no space for roaches to occupy in the house. So the condition will be, we want to check, we only create more or grow more roaches if the volume of the house is less than its capacity. Or we can say that the bulk volume is less than the volume of the house. So these are the variables we are going to use. And let's see the algorithm, then later we see also going to see the program. So this is the algorithm again. The first thing I'm going to do here is to get the input of the house volume, then get the starting population, the initial population of the roaches. Then we are going to assign the start population, initial population as our population now. So we want to know the total bulk volume. So it will be the population that we have now times one bulk volume. How many volume of the room, the volume one bulk will occupy, we know already it's a constant value. So if we multiply by that by the total population of the bulk, that will give us the total bulk volume. Then we initialize the count weeks from 0. We are starting from 0. Now you can see our loop. We say that if the total bulk volume is less than the house volume, which means we still have a space. So we have to generate new bulks. So the population times the growth rate will give us the new bulks. Then we want to know the volume of the new bulk. So we multiply the new bulks by one bulk volume, and that will give us the new bulk volume. Then we had the population plus the new bulks, that will give us new population. Then we had the new bulk volume to the total bulk volume, and that will give us the new total bulk volume. Then we increment the weeks by 1 because this happens, the growth is 0.95 per week. But now we are going to check if we have reached what? The total bulk volume has reached the house volume. So we check the condition. If total bulk volume stays less than the house volume, then we generate more growth and we follow the same. So until this condition is false, we stop. If we reach the total bulk volume is equal to the house volume, no space no more. Or if it's greater, no space no more. So this is the code. Again, here we say a program to calculate how long it will take a population of roaches to completely fill a house from floor to ceiling. So we have the growth rate as our constant variable, 0.95 per week. Then the bulk volume for 1 is 0.002 cubic feet. So this is our main program. We enter the total number of volume of the house. So we tell the user, enter the total volume of your house in cubic feet. So we use our scanner object to get the house volume. Also enter the estimated number of roaches we have in the house. We use the scanner. That will be our start population. So when we know the start population, we can calculate our total bulk value, which will be the population we have now, times one bulk volume. Now we declare new variable, name new box and new bulk volume. So now we are checking. If the total bulk volume is less than the house volume, because we already entered the house volume, and we already calculated the total bulk volume. If they are less or if they are equal, then we cannot, there's no space to generate new bulks. But if it's less than the condition is true, then we generate a new bulk by multiplying the population with the growth rate. Then we also calculate how many volume the new bulk occupies, which will be the new bulk times one bulk volume. And then we find the new population will be our new box plus the initial population. That would give us new population. Then also the same thing, the total bulk volume, we add it to the new bulk volume. That will give us a new. Then we increment our count weeks. So this, we have to keep doing this until our condition is false, which means there's no more space for bulks to occupy the room. So if the condition becomes false, we want to know how many weeks it takes. So first, starting with a roach population of whatever we had, and a house with a volume of what was given to us. After the weeks, so the count, if the loop runs only once, that means only 1 week it takes. If twice, then 2 weeks it takes. Then we can print out the total roaches we have of the population, and also the total bulk volume that we generated. So the main thing we are learning here, again, is how to use the while loop here. So we also have something we call the infinity loops. Infinity loop means, as we said earlier, the conditions always will be true, which means the loop will never end. It will execute forever. And what normally makes it possible again is because of the condition. Condition have to be false in order for the loop to stop. So we also have a nested loops. So a body of a loop can contain any kind of statement, including another loop. So we can have a program that we can write, a loop will be inside another loop. And we may see an example of that here. You can see what we are doing here. We have a do while, but inside the do while loop, we also have the while loop. So we can see the while loop here. So we have a do, enter all the scores to be average, enter a negative number after you have entered all the scores. We initialize the sum to 0, number of students to 0. Then we ask the user to enter a number. Now we say that the number user enter, if it's greater than or equal, so here we have another while loop. If the number we enter is greater than or equal to 0, then we can add it and then increment the number of students. Then we ask the user to enter another number. So we cannot get out of this loop until this condition is false. Then we check, okay, if the number of students greater than 0, then we're going to find the average. So the average will be the sum divided by the number of students, the average score. So number of students, no score to average. If we have if else here. So if this is true, we get the average. If it's else, there's no score to average, which means we didn't enter any score. Then system one, the average another exam. If we want average of another exam, then this is where we're going to check our while loop here. While answer dot equal ignore score is yes. Then we go through all over again. So here we have the whole concept is that here we have do while is outer loop and the inner loop is while. So if first we have to do something first. If the condition here is true, then we go back and do all over again. If the condition is false, then we stop doing it. So again, we're going to have more example of this in our next lectures, programming examples for looping. So this will be our conclusion of our lectures here. Again, the main concept we cover here is Java loop statement, the while loop and do while. In next lecture, we are going to cover the for loop. Then after that, we will go through some programs, examples, the lab work examples using loops. Thank you.